me for this Lunch and Learn is an introduction to AWS Step Functions. So the idea is to give you a pretty high-level overview of what step functions are, how they can be used, and how we use them. So it won't be super in-depth. You won't know every single little detail once we're done, but you should have enough of an idea to when they'd be useful. So if you're building a new feature, if you've got a new thing going on, this is something that could benefit, or if you need to actually work with the one step function that we currently have in the code base, you'll at least know roughly what's going on. So AWS Step Functions, basically, you can think of as the conductor for various AWS services. They basically let you implement pretty much every AWS service, whether it's Lambda, SNS, SQS queues, S3, and build pretty complex flows out of them. The way it actually looks is a bit more complicated. So this is a pretty basic example step function that we'll kind of be working our way through as the presentation goes on. So you see it generates you a pretty nice little flow chart going through various steps, visualization for various steps, which again we'll see once we get into the presentation. Interestingly, this is the JSON that mainly defines the function. It's not extremely, it's quite annoying to look at. It's over 100 lines if you were to scroll the way through. So one of the things that is a big benefit of this is you visualize things easily. Like you can show this chart to someone and be like, well, this is what's happening. And even if they don't have a technical background, everyone can pretty much read a flow chart. So again, just a little recap. What are AWS step functions? Like we saw in the first image, they basically let you conduct like a little orchestra of AWS services. You can think of it in a way as state as a service. So we work a lot with Lambda, which is functions as a service. You really just care about your functional code. How does it, what does it do? What's our business logic? Instead of setting up servers, anything else in the background really. And with step functions, you get a little higher level thing. You get basically managed state for each execution, which is then accessed by your various steps, whether it's a Lambda function, whether it's an API call to something external, whether you're saving something to a database. You've always got that overarching state management. Kind of like if you were thinking in a React context, a context object. We've got a context provider and you can kind of always come back to it in various stages. Step functions are state machines, which you might have heard Jake and me talking about, which are kind of something we're looking at more for the front end, but are quite cool in this situation. So basically you can think of it as a function or a system in which every possible state is mapped out. So you always know where you could end up, and you also know each possible state transition. How can I get from A to B to C to D? So it's pretty easy to visualize, it's pretty easy to read and just debug, because you know every possible state you can be in. And finally, basically they're used mainly for multi-step workflows, and they can be very useful because, like I say, they dynamically generate that nice little flowchart for you, and we'll see more about it later. So some example use cases before we get stuck in. When is it actually a good idea to build a step function? Like I said before, we have one in the code base currently, which handles our development approval processes. So basically the workflow is, client puts in a request for development work. We look at it, build a feature, send it to the person who made the request. They approve it. If they do, it goes to either a stakeholder in the client's company or the director. They also approve it. Each step we get validation on what's happened. Each step has a certain timeout, like a minimum or a maximum response time that they get before things get denied. And it's a nice little chart that's really easy to follow through in this case. Some other ideas where they can be useful is stuff like data ingestion. So if you upload an image, the thing that's happening on the background on the website will probably be storing it, gathering metadata, doing some rescaling, reformatting, and all this stuff in a step function can be nice and easily organized, done in parallel, and just neater than doing it really anywhere else. And then we've also got batch jobs, which are basically jobs where you're doing a lot of operations again and again. It's pretty easy again to have a predefined flow, and unwindable flows, which is one of the examples that AWS give, which is quite cool. So the idea is that you have a workflow in which each step depends on the previous one. So A depends on B depends on C, depends on D. But if any step along the way fails, you need to undo all the previous work. So you have to do A before you can get to B, but if B fails, you need to undo what you did in A to keep the system stable. And as we'll see later, it's very easy with step functions to define error catching and then define a flow to follow once an error has occurred, making it pretty easy to undo your previous work. So we'll go over the benefits. I've got some quick notes here, and then a few of them will go into more detail as well. Basically, just get this on. Step functions are serverless, which is great. We try and keep pretty much everything we do these days serverless, so any AWS service that conforms to that is useful. They're very observable. As I said before, you get this visualization. We'll see later, you get the visualization for every single execution. Ease of debugging is a lot bigger. It's not a lot easier. And longevity, basically, a step function can run up to a year, as opposed to Lambda, which these days has a maximum limit of 15 minutes. So, in a bit more detail, again, the slide we had at the beginning, this is our visualization. You write lots of code, you've got lots of little functions, but at the end of the day, you end up with a nice little flowchart, which you can show to stakeholders, and they don't need to know what happens at each step, but at least they'll know what the steps are, how the process works more or less. In a similar vein, we've got observability. So this is what this would look like if you're looking at one single run of the state function. Again, it's not super intuitive, but basically we've got a nice little legend down here, and we can see each step succeeding. We can see at some point it ran into this error, this bit over here. There was a failure. We went into a fallback. We went back to the first function, ran it again. And it basically means that instead of going through a long set of CloudWatch logs, you just look at one nice image and you're like, oh, this is what I'm more interested in. In a similar vein, when you come to debugging, you get this log, which shows you basically each single step. I've started the step, done a step, this is the output of the step. If there's a failure, again, you see it right there. You see which step you're in. If it's, for example, a Lambda function, there's some nice easy links to click to go right to the relevant logs. You're also able to rerun every single execution with the same input, which can be extremely useful if you've fixed error code. So you have Lambda running, there was some obvious errors, you went in and fixed the Lambda, you now want to run it again. You don't need to go to the client or wherever and try and retrigger the thing. You just click run execution again. It'll run it with the same input. If you've successfully fixed the error, that's it. It's now fixed. The thing is run and worked. Finally, longevity of it. Like I said, Lambdas, for example, have a 15-minute runtime limit. Most tasks, that's fine, but sometimes you need more. Also, if you need to wait for user action, this makes it extremely easy to say, the user might be on holiday, they might be gone for 2, 3, 4 weeks, but you can still wait your maximum 1 year. So really any reasonable case, a step function execution will be fine. There are a few downsides, none that I really consider big issues, but it's sensible to bring them up. First off, step functions are costed by state transition. So basically each time you switch from one step in the flow to another, you pay AWS on top of the fact that you obviously pay for using the actual resources you're using. So it can end up a little bit more expensive, especially if you've got pretty complex flows that run a lot. But I think as far as we're concerned, it's pretty negligible. You save so much time by not having to, by having to do a lot less work to get a complex workflow going, that pretty much more than makes up for the extra cost in pretty much any situation. The second one is it's written in Amazon State Language, which sounds worse than it is. It's basically JSON with a few extra abilities that AWS have added in, but yeah, there's not much to it. It's pretty simple to read, it's pretty simple to get once you know what each thing is, and since we're using serverless, for example, there's a great plugin for the actual serverless framework that makes it a lot neater to actually write step functions. So depending on what you prefer, you can completely avoid using the state's language anyways. And finally, again, not really something that will be relevant for most use cases. Execution history is only retained for 90 days. So if you do have a thing where, you need to have strong logs for years and years, it's not the way to go unless you put in some pretty complicated extra logic to export all the history to S3 or whatever. But again, in most use cases, 90 days is more than enough for debugging, and that's all you usually need. So, how do we actually use them? Or what are the usage benefits? Like I've said, we hold state in between tasks. There are 7 different types of states or steps that we can take. Naming is sometimes a bit confusing. So they're step functions. They hold state, in general for each execution. However, each single step in the flowchart is also referred to as a state. So I'll probably call it steps quite a bit. If you read the official docs, you'll be passing state into a state, which if you read it the first time can be a bit confusing, but just think of each execution state as a step. I've got really strong support for error handling and retries, which we'll see once we get into the tasks as well, which is great. It's got some default retrying. We can get really fine-grained in how we want to change things. We can catch errors and specify workflows to follow after an error has occurred, very specifically down to each type of error follow a different kind of flow. Yeah, and like I said, you can write it in either the console or serverless, which both have advantages and disadvantages we'll get into. So the first thing we want to look at is the main functionality, so to speak, the state management in the step function. Like I said, you've basically got a global state object that can be manipulated by each state or step. Again, kind of similar, I think, as a little bridge for thinking if you've used React Context, it's quite similar to that. You can access this global state on basically $, when you're passing things in the definition, as we'll see later. You access global state by $. It's basically just the name of the state variable. By default, each function will receive the full state object as input. You can manipulate this by passing in specific keys as you want, and each state will again, by default, overwrite the global state once it's finished with its output. But again, that's something we can manipulate as we please. So you can either overwrite the global state completely each time, or you can treat it like object spreading, where you just add an extra key each time you're done. Finally, you also have access to some metadata, which is basically stuff like when did this execution start, what was it started by, which you can access on a second global object, which is stored as $. Most cases you'll never need this. There's one specific case when you're waiting for asynchronous execution, so it becomes relevant, but we'll get into that later. So this is pretty dry, so I've stolen some images from the official docs, which are really useful, and which will hopefully help make this a bit clearer. So it's basically our global state, which we'll have at the top level, which you can kind of see here. And there's tasks in between, like each execution is one task, and you can define, well, you can change or affect that state with 4 different options. So basically we've got our main state coming in. Say it's one object, we can specify the input path, so we specify 1 key, for example, if we only want to pass in 1 key. That's the first modification. Then we've got parameters which are set in the actual definition of the state machine, which can kind of be ignored, but it's stuff like pass in the current date. You don't really need to get that from the global state. You can just say every single function will get the current date, for example. And then our service runs, whether it's a Lambda function or anything else, we get the result, and then the result path is basically where you say, where do I put this on the global state? If you don't define it, by default it just overwrites the entire state, so the output of whatever you've done is now the global state. If you provide a result path, it goes onto that key, call it result or whatever. And then the output path can filter that further. So basically, say I've got an object with 10 keys back out of my Lambda function. I only want the one key. Specify that key in the output path, and that's what gets passed to the next function as input. So you've kind of got to think of this as a constant cycle until you get to the end. You get input of global state, you do stuff with it, you specify which bits of the output you want, that gets passed to the following task. A little bit more visualization to try and make this easier. So we've got two main use cases. On the left, you replace. So we've got our state input, just an object, 3 keys, column details who. We run our task, whatever it is. It gives us a string back. By default, that string will just be put on $. So the state that we have, which was previously an object, is now just a string. The next execution, next task that runs will receive that string as input. Alternatively, if we specify a key on our global object, goes into task result, and you can see here in the following state output that gets passed to the next step, it's just one extra key. I think that's the easiest way to think of it. It's one of those things where once you use it quite a bit, it becomes natural. When you read it in theory, it's a bit like, yeah. I'd say state management, though, is the most iffy bit, where you need to wrap your head around, and once you've done it for a bit, it's quite simple. So the next thing we've got is the 7 states, the 7 steps of step functions. Basically think of them as little workers, kind of like these. We've got 7 different ones, although I kind of cheated by making fail and succeed one state to get that image in. And again, you don't need to memorize any of these right now. Just the idea, there are 7. We'll go over each one of them. Some of them are pretty cool and interesting. Some of them, like pass, do basically nothing. So varying degrees of interest there. In general, each state will have some common fields. This is the JSON AWS State Language. On the left, it's not that important. Basically, the idea is whenever you define a step, you'll need to specify the type of state it is. So is this a pass state? Is this you waiting? Is it a choice? Just to define for the functionality, what is this? And you need to specify the next state you want to go to by name. Because again, as I said, it's a state machine. Every state you're in always has one next path to go to. You also need to specify if it's the end step. So basically, if you're done on this level, you'll have to specify end true. Don't specify end false. If you specify next step, as long as the end key is there, it expects that to be the end step. And it currently throws an error. I think previously at some point it would just crap out. These days it'll throw an error, say you can't have next and end. But that's it really. You can add some comments on each step. And then we've got that input-output path manipulation that we were talking about previously, where you can kind of filter what goes into the state, what goes out. So the most basic of our steps is pass. And it doesn't really do much. It literally takes an input, passes it to the next step. So really the only time you're using them is if you're using placeholders to develop stuff and you're not really sure what will I want to do here. You put a pass there so you know something will happen. I'm not sure what yet. And you can use them for debugging, I guess. It says that in the docs. I'm not really sure how useful it is because you can't see the input and the output, but you can see that for each other state as well. So really treat them as placeholders. The second state you got is wait, which is also very self-explanatory. It literally waits. So you can pass in the time to wait either as seconds or as an absolute timestamp, so it'll wait until that time. It's quite useful sometimes when you're working with external APIs, for example. You might make a request to an API that won't return a promise that resolves once it's done, but you'll just know, well, I think this call will take X amount. Or, you're calling SES, you want to send an email. SES will just tell you, I've sent the email. It'll probably take another 5 to 10 seconds until it arrives. You might only want to take action when you're sure it's arrived, so you'll wait a minute and then keep going. Similar thing, if you're interacting with some external stuff and you know that you'll maybe hit a rate limit or something, you wait 5-10 minutes, you keep going. You can, instead of passing them in, which is quite useful, can take the time to wait off the input object. So you could have a previous Lambda running that then says, it returns a date, and you then wait until that date happens to do whatever it is you want to do. So they can be quite useful wait states. Next one is fail and succeed. Again, extremely self-explanatory. If you don't want to have one of your other states specified as an end state, you can use these states. Type failure will simply, once reached, end the execution and log a failure. You can put a cause in, so it's basically like an error message. And final state succeed, type succeed is literally just that, you're done. If you want to intentionally fail and log it in the execution history as a failure state, this is the only way to do it, by putting a type fail in and actively reaching it. Stuff can error, but then it's a lot more of a pain to debug. So really what you always want is target a specific failure step, and then you'll have it in the logs. It'll be a lot easier to kind of move on from. Now, next one, this is the important one really, is task. As far as I'm concerned, everything else is kind of the building blocks. It lets you, specify the path of how do I want to get to specific tasks. How do I want to get to some actual action being taken. You've got quite a few things that you can do as tasks. Like I said, you can call message queues, you can call databases. The main thing we use it for is lambdas, so that you actually call a function, do some logic, move on. You can call external services through a workaround called activities. I say workaround, it is an official part of the spec, but it feels quite clunky compared to the entire rest of the step function system. They don't really support asynchronous executions. There's quite a lot of pieces where we refactored our code away from using activities. So it's a nice thing to know. If I really need to call an external service, I can make it work. Generally, you'll probably not want to. So you've got two code blocks on here on the left. Like I said, there's two ways really of writing step functions. You can either do it with a serverless plugin using a serverless framework, or you can write the JSON. This shows you how they look slightly different, but really it's the same thing. You've got your type, which is task. You've got some resource names. Here we're getting it from the YAML using a little subfunction. Here it's actually written out. Got a result path, which is where on the global state object to put our output. And that's really it. So there's some extra things with tasks. You can retry and you can catch, which is, like I said before, really, really useful. You've got again, the same definition here written in both languages. And you can see we've got some retry written out. We've got an error equals, so on what error to do which retry. I've written it as all errors, which obviously in most use cases you want to be a lot more specific. You want to control for 500, a timeout error, whatever you really have. But here we've just got everything. And we can specify how often we want to retry. We can specify an interval in which to retry. We can also specify back off, so start at 5 seconds, then add 20, next retry, do a bit later. And yeah, it's just, it's built in, it's really easy to use. For a lot of this stuff, if you were to write exponential back off by hand in a Lambda, it'd be a pain really to do. This way you've got a few variables and that's it. On catching, very much the same thing. You specify what kind of errors you want to catch. You can pass an array as well, so you can have one catch several types of errors without just specifying all. And then you specify a next state, which is, like we said before, you basically say, okay, if this error happens, go to this place in the step function and do X. A bit more visualization, back to a slide that we had previously. So in this case, what's happened is we started our execution, it started here, generated the number, called it into a choice state, which we'll come into in a second. We call the task and it fails. Because in the previous slide we saw we've got our catch all fallback, and we said, well, next go here. We move to the fallback, which just passes the data on to the next step, which is generate number. We go again. I mean, obviously, in a real scenario, you wouldn't want to go back to the function that originally caused the error. But this is, just a nice little simulation that can either fail or succeed and show us some more states. So the last thing that tasks are pretty cool at these days is that you can have a callback pattern. So like I said earlier, you used to call external services or asynchronous calls like waiting for an email using activities. These days, you can call most AWS services, definitely Lambda, the message queues, and the databases, and append to the invocation wait for task token. What you do is you go to the global state object, which is held by state functions itself, which can also give you a task token for that one execution. So say I start one execution, I know it will send an approval email to some person. Basically, once this execution runs, I get a unique identifier set and stored in our global state, which I can then use when it's waiting to restart the execution. So basically what will happen in this case is we'll call our Lambda, it'll send an email. As part of the inputs, we'll pass in our task token here. We send that in the email into a link that our user will click, and while we wait for that link to be clicked and the task token to be used using the API to restart this, the step function is basically waiting. And as I said, we've got up to 1 year in which basically all our state is stored safely in AWS servers, and if the user clicks the link 6 months later, that task token is used to restart this specific execution. It's really neat, and like I say, it's only supported on some AWS services, but really the core ones as far as we're concerned. And the old thing that was replaced by this is activities, which required you to constantly poll a server for changes, which was just a pain, really. This makes it a lot easier. And this is, again, one of the more advanced usage patterns, so don't worry if this doesn't initially make sense. So, moving on for the states, we're getting to the more interesting building blocks, so to speak. Next one is choice, which, again, name is pretty self-descriptive. We're entering a state where we compare the incoming input to various rules we've set up. In this case, pretty basic. Is the number that we get as an input 1 or is it 2? And depending on which result is chosen, so to speak, we move on to different steps. So this is where you can branch out your step function into far more complicated workflows. You're not limited to just 2 choices. You can have 20 in there and have 20 branches. It'll obviously get quite complex to read, but the only limitation on choices is how many do you want to build out. We can compare quite strongly, so we can compare Booleans, strings, numbers, and timestamps. You can't write your own comparison logic, which can be a bit annoying sometimes. You can't just pass in JavaScript and say, run this comparison function, but you have a pretty exhaustive list of operators in Amazon State Language that you can use.
So did you say you can or can't?
You can't pass in your own ones, yeah. But again, it's pretty all right. Worst case, you could run a Lambda as a task and then have that output something. Next step is parallel, which is basically saying when you receive this input, run these X amount of tasks in parallel. So coming back to the example I had earlier, say you're processing an image upload. You've got your input of the image. You say, well, at the same time, extract metadata from this image, store it in S3, run a Lambda to scale it to different sizes and store those. And then only when all of these tasks are done will you move on to the next state. So you can kind of think of it as similar to promise all in JavaScript. We'll have, at the end of the output, we'll basically have an aggregate of the outputs of each individual parallel task that was called. And yeah, the downside here is we do need to specify each parallel thing in advance. So this was, it doesn't sound that annoying, but for example, if you think of having an array of inputs, you couldn't say run in parallel this one function on each of the things. You could say, for the whole array, run things at once, but not triggering each individual thing like a map. But in October last year, they added a new state, which is the map state, which pretty much you can think of as literally map in JavaScript. There's a few little changes, but that's basically how it works. You pass in what's expected to be an array, and you say run this entire flow on that array. So you don't have to just say do one task. Basically, you can think of a map state as a little state machine in your state machine, which will run on every single item in an array. It's got some cool things where we specify the max concurrency. So you can start off at 0, which makes it kind of pointless. So it'll really run every single thing one at a time. You can specify really high concurrency though. So if you're doing a Lambda to operate on stuff, you can go up to 20, 30, 50, however many you want. Which also is quite a nice workaround for the fact that Lambda is sometimes quite a pain when it comes to setting concurrency. Because you can set the max one, but only using reserved concurrency. Other issues that don't really matter for the scope of this talk, but it's a lot easier to set the concurrency of a single Lambda for something with this than really any other situation. Just as an example of a use case here, because it might be a bit convoluted, say you've got a message queue, like an SQS queue, it stores 50 messages. You say when there's X amount of messages in it, trigger the step function, and then you have your map state run over each of the messages, doing the same work for each of them. So that's our 7 states. Again, don't worry if you haven't taken all of them in. Just consider them as building blocks, which you won't always use. Like a map is pretty advanced and will probably very rarely actually be useful. Like I said previously, there is a difference in writing. So I'm just going to go a little bit into the difference between writing things in the step functions console versus in serverless. So as you can see, the code looks quite different. This is the exact same thing happening. It's a lot more verbose if you write it in the AWS console. And writing JSON, I find, can sometimes just be quite annoying, having to write each of the quotes. Autocomplete isn't great for brackets and stuff, so you need to be paying quite close attention. You could write it on your IDE and then paste it in, but at that point it's getting quite complex. Serverless's notation is a lot shorter, especially once you come into complex bits. I think the example step function I wrote here is 113 lines of JSON and about 60 lines of text and serverless YAML. So that's a lot less stuff to write. Got a few pros and cons here, so you don't just have the code to look at. In the AWS console, and this is one of the things that I should have probably mentioned in the downsides earlier, there is no versioning on your step functions. So if you make a change, that's the change. All previous running executions will run with what they were started with, and you can open in a previous execution to see what the step function looked like then, but you don't have actual version control if you've made a change. Whereas if you're using serverless, of course it's in a YAML, which hopefully is in a repo, and is tracked by GitHub, so versioning is obviously a thing. Other things, in the AWS console, you have instant validation of the things you write. So not only will it tell you if you've got unreachable states, if you've got some sort of error, once you click save, it will also automatically build you a new workflow, so you can visualize those changes quite nicely for yourself. If you're using serverless framework to write, you'll need a package which does some of those things. It'll tell you if you've got a state that can't be reached, or it'll tell you if you're stuck in loop somewhere, but it doesn't give you any visualization. It's not great linting either. Apart from that, yeah, if you work in the console, you obviously have to write in JSON. And one problem that's more about our setup, I guess, than anything else, is if you write in a microservice a step function that relates to it, and you want to rebuild it, you have to redeploy the whole project. for the whole thing to be updated in AWS, which can take a few minutes, whereas if you're writing in the console, it'll just be instant. So that's more or less it. Looking at our little visualization, we now know each step. So we've got just to walk you through it without this code, we've got a basic pass at the beginning. We're calling a task, which generates some sort of output. We've got a choice state, which is where we branch. We've got some catching over here for errors or success going through. We've got a wait state, which waits a bit. This is a parallel state, how it looks in visualization. So you basically branch out, you do these two tasks in parallel, and then you also, on the right-hand parallel side, finish this one. Once they're all done, we move on to the next step, which in this case is a map task, which basically just runs over each single thing, puts something out. Cool thing about the console as well, you can click on your map and you can literally look at every single execution, so at every single map in there, which sounds less good now that I say it out loud, but if you're actually doing it to debug something, is really useful. And then, finally, we've got a final state, and our choice has a default state as well, in case none of our previous choices were hit. A final little thing, how do we actually start a step function execution? You either use API Gateway, it's got pretty good integration with that, you don't need to set much up. You can trigger off CloudWatch events, which is quite cool for complicated integrations, because you can watch basically anything and start a step function. AWS have a good example of basically running step functions when IAM roles are created. So it'll automatically do some validation, then send an email to someone, say, hey, is this role really something you want? Office 3 events, so basically any storage events, like I was saying, data ingestion. And then this is the actual step functions API, which is the most direct way to interact with things. Finally, just a few tips and tricks. It's not that many. I really think it's a pretty straightforward thing once you read the docs and play around with it a bit. The main important thing is you do want to specify timeouts for each tasks, each step. So as I said, it can run for a year. If you have some weird interactions with a Lambda function, for example, you might call a Lambda function, it might fail. AWS step functions might not read it as a failure if you haven't provided a timeout, despite the fact that your Lambda function is gone after a max of 15 minutes, the step function execution could, in theory, wait for up to a year. It could also start looping. Again, a step could, for some sort of failure, like bad logic, start looping in the Lambda, keep on calling itself for a full year. So what you want to be doing really is having timeouts on each bit. The second one will make more sense once you start writing it. Basically, if you specify any AWS services in a task as something to be run, there's two ways of noting it down. You can either just pass in as a resource the entire ARN code of that service, or you can use parameters where you say, use an AWS service, use Lambda, use this name on dev, which makes it a lot easier to understand what you're really looking at, and also is the only way that works with task tokens. So if you do want to suddenly have async operations, you'll need to write in parameters then, so you might as well always do it. Finally, like I said, old executions won't update their definitions while they're running. So you can make changes to your step function at any time, but you need to bear in mind all the stuff that I've run previously won't change. It might show you the main definition with your cool changes that fix bugs, but all the previous ones will be stuck on the old code, which can be a bit of a gotcha if you're not aware of it from the get-go. That's pretty much it for me. There's a few extra bits that you might want to look at. You'll get access to the slides, so you can click on the minified links. But basically, there's two really good talks by some AWS evangelists about how to build stuff with step functions, which is I looked at quite a bit when writing ours. Jan Shui's got a course. He's great. Only downside is it does cost some money. But if you want a real deep dive, I think that's probably the best way to go. And finally, the docs are quite well written. There's a few little trip-ups where they're sometimes a bit out of date, as can happen with AWS docs, but they are good with good visualizations. Like I used some of them there. Also, I've already written 2 blog posts about step functions, so you can also look at that. Yeah, that's it from me. Does anyone have any questions? Sure. So the question is, why wouldn't we be using these all over the place already? I think partly because not everyone's been fully aware of them. I think we've got quite a few workflows where they could be very useful. It can be a bit of a pain if you've got a full workflow set out and you want to completely refactor it into step functions. You've probably got some lambdas doing step management already, which will have been a pain to write, but refactoring it completely into a step function will also be quite a bit of extra effort. I really think we should be using them a lot more, full stop. I mean, you know about them now, so that's a big benefit, I think. Yeah, that's all I can say. Can you interact with them when they're running? No.
Not at all.
You can look at them. You can see what state in the execution the step function is currently in. You can't make changes to it. So you can't look at it, if it's gone through 2 steps, you notice, oh, the email's wrong. You can't go in and change the state there.
You can cancel it.
Yeah, you can abort them.
Yeah.
You can abort any execution. And like I said, you can restart it. But you can't actually go in and change, for example, the global state while it's running.
But you can observe it.
But you can observe it, yeah. The observability is actually, I should have pointed that out more clearly. Observability is great in that case because you can go into each execution and see, well, where is it? What are we waiting for? What's the problem here? Cool. Well, that's it. Thanks.
Thanks.